This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. I have with me today Brent Laster. His day job is a senior manager in R&D at SAS. Brent is also the author of two books, Professional Git and Jenkins 2 Up and Running. I'm going to read the subtitle of that book, Evolve Your Deployment Pipeline for Next Generation Automation. He frequently presents trainings for O'Reilly's Safari on Git, Jenkins, deployment pipelines, and continuous delivery. He's also a regular presenter at OSCON, DevOps World, Jenkins World, Rich Web Experience, and other conferences. Brent, welcome to Software Engineering Radio.
Thanks, Robert. I appreciate the invitation to appear on the show.
Would you like to add anything else about your bio that I didn't cover?
I think that covers it pretty well.
Okay. Today we're going to be talking about Jenkins 2, the subject of your book, and we will link to that book in the show notes. Jenkins is a build server. We're going to work up to a discussion about Jenkins, but I want to get some background concepts in. Could you give us a brief review of CI/CD? We've covered that on a couple of shows, 221 and 211. So listeners can go back and listen to those, but let's get a quick summary of that.
Sure. I tend to think of CI and CD, these continuous ideas, continuous integration, continuous delivery, as being kind of like an assembly line. And continuous integration is the process that kind of kicks off the assembly line. It's the updating source code out in a source management system and having some process like Jenkins that monitors those repositories and then kicks off the rest of the pipeline from there. That goes into what's generally called continuous delivery, the larger set of getting your code from source management through testing, building, all the pieces of the pipeline, and kind of putting it through more and more what we call continuous testing, more and more broader sets of tests there to prove that it is of a high quality, that it works well with other pieces of code, other things that have been built through the pipeline, and down into you get to continuous deployment, the idea that you have produced something that is of a high enough quality and works well enough that it could be deployed. Doesn't mean you deploy it every time, but you have proven that it can be deployed, so it goes to that assembly line and you get something out the other side from your source code change that you would feel comfortable deploying to customers if you chose to do so.
Could you clarify what is continuous about it as compared to plain old integration and deployment?
Well, so continuous is kind of perhaps an overused term in a lot of cases, but continuous implies typically a couple of things. It implies that it's a repeatable process. It's more of a discipline or science than an art. It's not somebody handcrafting processes together. It's something that can be reproduced. You give them the same inputs, you get the same outputs out there. Also, it is expected to be fairly fast. There's an idea of fail fast in the process. If it's something is not going to work, you want to find that out quickly. But you also want to be able to produce something that is deployable or eligible to be deployed in a fairly quick manner. So some companies will do it as often as multiple times a day. Some companies will choose to do it once a day. It depends on there. But it is more of a repeatable, fast process to get the source code changes through there.
In your description, you used a couple terms, pipeline and assembly line. Drill down into what you mean by pipeline.
So, pipeline can have a lot of meanings, but typically the way I think of it is the set of processes that are chained together. The set of processes for what it would take to take your change from source code again to a deliverable product out there. Those can include processes for compiling and building the code, doing unit tests, functional tests, integration tests, gathering source code metrics, putting them into repositories with other artifacts, combining them, getting them ready for deployment, putting them into containers, all those kinds of things. So a pipeline, in simplest terms, would just be a chain of processes linked together.
And those are things you need to do every one of those things for a change to be production ready.
In most cases, yes, although pipelines actually may have some points of human interaction in them. For example, a user acceptance test might be part of the pipeline where a user wants to go in and try some stuff out, make sure that stuff looks in the user interface. So there are typically pieces of the pipeline, they all run automated, but there may be points along the way where it's incumbent upon a human, or where it's desired to have a human say, yes, I want to go ahead and proceed to the next stage.
We're going to now move on more specifically to the Jenkins piece. Jenkins is a build server. What is a build server?
Well, it's primarily been used for builds, but it's really an automation tool. It's a workflow orchestrator, and that's perhaps a fancy way of saying that it can automate processes and connect them together and monitor them. So that's where it really comes into its power there, is being able to model processes, define them, and link jobs together as code now, write out your pipeline as code in there, and be able to monitor and report problems and execute it, be able to run this kind of pipeline. Now that can be a lot more than builds. It can be all the pieces of the pipeline, the testing, the running other applications, for example, to gather metrics and to do all the different pieces.
I think of build as compiling or maybe merging a large number of files into some kind of an archive. You're saying that's really something we started out with, but the term, it's much more generic now and can apply to almost any step that you need to do to get your code ready for delivery.
Right. The gentleman who created Jenkins, which was originally called Hudson, Kosuke Kawaguchi, and I'm probably saying his name wrong, and I apologize for that, but he said he got tired of being the guy who broke the build, so that was why he originally created Jenkins. The idea originally was as more of a CI, that continuous integration, monitoring for changes coming into the source management system, and then kicking off builds. But then as continuous delivery, this idea of continuous delivery has evolved and has grown in popularity. Jenkins was a logical tool to take that and to implement the other pieces of the pipeline downstream. So today we can really use Jenkins and the functionality it provides to drive any other number of applications in different pieces or processes to make up an entire pipeline.
You may have answered this already. I'm going to ask and see if I get something else back from you. What is the role of the build server within the CI/CD process?
So depends on what you kind of mean by the build server. Today we typically would talk more about like a build application that is probably run by something like Jenkins. These days it might be something like Gradle, or in the past Maven, or any number of compilers or applications that actually build the code. The build server typically, or the build system, is typically where the process takes off and starts after you have code pushed into source control, and something like Jenkins has detected it and kicked off the builds. The build is the first point of identifying a problem or failure in there to make sure things look good. These days, they typically will also encompass unit testing in there, individual tests to be able to make sure that code changes work kind of in isolation, giving the same some inputs for a function, you get the expected outputs in that. So the build is the first place in there where you want to validate that your code looks good. Typically, though, that's in isolation, and then you move it on down the pipeline to test it out with the other pieces.
Let's move more specifically into Jenkins. We've been talking about general concepts that could apply regardless of the tool. Situate Jenkins in the landscape of comparable tools. What does it do? What is it good at?
So that's a good question. So Jenkins, as I said, is kind of an orchestration engine. That's probably a workflow tool. That's probably the best way to think about it. it allows you to tie other tools together into this sort of pipelines that you need to do, or do monitoring on other things out there. With the Jenkins 2 release, which is what we kind of used to call the Jenkins 2.0 and beyond, it's changed from the interface. The interface used to be more of what was called freestyle. You would interact with the web forms and you would select stuff from drop-down list. You would type stuff in fields. With Jenkins 2 now, you can essentially write these this orchestration of processes just as you would a program. You can write it in code out there, and you can store it even with your source code in the repository, and Jenkins can monitor that code as a change. So this really ties into the whole DevOps idea here, of being able that your infrastructure, your processes can be expressed as code as well and be monitored and pick up and cause a new run of things when something changes out there.
That's a really important point. I want to drill down more into that. I've been doing some work within the last couple of weeks with Jenkins. One, every other server we manage in my DevOps group, the configuration management tool will generate a conf. If you have an ABC server, it would generate abc.conf. Using templating, it can function as a programming language, do anything you want to get the right conf, drop it on the server, and then tell the server, hey, reload conf. Jenkins 1, the server can modify the configuration file, and it's not under source control. So it's not DevOps friendly. So it sounds like Jenkins 2, the goal was to make it more compatible with how DevOps works in modern environments.
Absolutely. As you said, in the earlier versions of Jenkins, typically your configuration was stored in XML files out there in the Jenkins home directory, and you had to back that up or use a plugin or something to keep track of changes to it. And with Jenkins 2, they have really made writing your pipeline as code, as we call it, being able to express your infrastructure by coding it up in a Jenkins application and storing it with the source control. They've really made that a first-class construct out there. It's one of the primary focuses of Jenkins 2. And again, it really does tie in nicely to the whole DevOps infrastructure there, because not only can I code up my pipeline in the Jenkins application itself and test it that way and evaluate it and make sure it all works, I can also store it as what's called a Jenkins file, an external file that has that code in it, put it in source control, point Jenkins at that, and say, watch this, just as you would for source control for a continuous integration. Watch this file, and if something changes in that file, go out and create a job to automatically run my pipeline based on what's in that file. So it really does carry Jenkins to where it needs to be in terms of really integrating well with the DevOps ideals.
You mentioned the Jenkins file. Talk about what goes into the Jenkins file.
So Jenkins file is basically storing the code that you type into Jenkins, that you would enter in Jenkins, or you can do it directly into a Jenkins file, but it's storing the code that describes your pipeline as in a external file. It's like if you think about like a build script or something that has a certain expected name, maybe like the Gradle build file, that sort of thing. A Jenkins file is the Jenkins piece of that. It's the name Jenkins file. It's just a text file with the program code to run your pipeline out there. They do have a couple of different formats that you can express your pipeline in, one called scripted syntax and one called declarative syntax. Scripted syntax it's basically Jenkins steps, DSL being domain-specific language, that are supplied by plugins out there. Any plugin you put in Jenkins can supply steps that you can use in your script. So a scripted pipeline is those steps and Groovy code, Groovy programming language. You can use that in there. The declarative syntax is an alternative way to write your pipeline. It again makes the steps available, but it's more about declaring what you need instead of doing the kind of imperative coding, just saying I need these tools, I need these applications, those kinds of things. and letting Jenkins figure out how to do it. They're both pipeline as code, just alternate syntax, and some are easier for some people to deal with than the others.
We did a show a while back on declarative programming in DevOps. Many DevOps tools are declarative. What is your view on the pros and cons versus the scripted Jenkins file versus declarative Jenkins file? And which one would you adopt if you were starting a new project?
So that's a good question, and I did a lot of consideration looking at this when I was writing the book and talking with people there, and everybody, of course, has different opinions about it. So it originally started with the scripted pipeline, scripted syntax. You have more flexibility and more freedom to do the kinds of things you would normally do if you're a programmer out there in terms of adding in loops into your code or using any valid groovy syntax, defining variables, even those kinds of things in there. So if you're a programmer by nature or you want to have the flexibility to use kind of constructs like loops or variables and those kinds of things, then scripted syntax is the way to go. The declarative syntax came about because the Cloud Bees, the ones who contribute, and the Jenkins community wanted to make it easier for people who were coming from the original Jenkins. In the original Jenkins, prior to 2.0 versions out there, as I said, you normally filled in web forms. You had fields that you would fill in or drop down lists and stuff. So it was very much about a very structured process there to defining the jobs. And declarative feels more like that. It's a very well structured, you have a very well-defined structure out there to use to fill in information about what you need. So if you are not a programmer, for example, and coming just from using Jenkins before, declarative may feel more comfortable to you. You have to realize, though, that declarative is a bit, in my opinion, more limited in terms of having less flexibility and stuff, because not everything can be done with all plugins necessarily without like defining variables and stuff in there. The other thing about declarative, though, is it is much better because it is structured about checking for syntax errors and identifying where problems occur in your code, because it can monitor the structure of that. It also is a better fit for their new GUI interface out there, Blue Ocean, because declarative is very structured and structure objects can map better into a visual interface out there.
You mentioned the ability of plugins to supply different keywords or tasks that are used in the Jenkins file. Give examples of what are some of the more useful or popular plugins.
Well, certainly, of course, you have source management plugins out there like Git, which supply a Git step that you can put into your program to say Git, and you can supply a branch or a location for the repository out there. Probably there are some that come with the code, like the shell step, the SH step to run code out there on a Unix shell, or the bat step to run stuff on the Windows thing out there. But any plugin that you install that is compatible with Jenkins 2 is expected to supply a step that can be used in the pipeline code now. So any of the ones I use, like SonarQube for code analysis or Artifactory, different ones, they will all supply steps that you can use and hook into there. There's a wealth of plugins, and in fact, that's probably why the Jenkins is as popular as it is. It's just because of the huge number of plugins that are available for it, and now they all should supply steps that you can use in your code.
Does Jenkins provide a plugin provider interface so that anyone in the community can create a plugin and it should work?
Sure, there are examples out there of how to create plugins and how to work with them. These days, the plugins, again, are expected to provide those kinds of steps. They're also expected to be reentrant, meaning that if the master server, the master node goes down, that they can survive a restart. So you have to make sure that plugins can serialize their data. They can write their data to disk and pick up again if the master stops from that. But within those kinds of boundaries, certainly you can write plugins out there. Jenkins also supports a feature called global variables, which is kind of like defining an object and methods associated with it that you can add in as well. You can use shared pipeline libraries and bring things in well. So certainly lots of opportunities for people to develop new code and new functionality and contribute back.
You mentioned this idea of plugins being reentrant. We did an earlier show on workflow management systems. As you pointed out a few minutes ago, Jenkins is a workflow engine. One of the characteristics is these jobs, which you call pipelines of multiple steps. You could have different failure modes that could occur between steps. Is Jenkins able to reliably complete a pipeline in spite of different kinds of failures that might occur, or system restarts, things like that?
The idea with Jenkins 2 again is that the system is supposed to be reentrant, or the job should be reentrant, and that's dependent upon the plugin's ability again to serialize their data out to disk and be able to pick up then if something happens on the master side. So to that degree, yes, it is reentrant in there. Now, when you move from like coding in web forms to actually writing your code as writing your pipeline as code out there, especially like in the scripted syntax, there's more responsibility on you to be able to handle exception cases. So just like in any programming environment, like Java, Groovy, those sorts of things, if you're using scripted pipeline syntax, you would typically use like try-catch functionality to be able to catch exceptions and then handle those well. You kind of have to do that in the scripted pipeline to get that post-build functionality that you used to get for free in traditional Jenkins, the thing that says, no matter if my pipeline succeeds or fails, I'll still send email to notify people. So you have to kind of work around that a little bit with these kind of programming constructs in scripted syntax. In the declarative syntax, they've done more for this, and there actually is a post section directive there that you can include in your code and just put that in there, and that will always get executed at the end. So it's both a combination of what the plugins provide in terms of being reentrant and being able to pick up again, but also there's some responsibility on you as the coder of the pipeline to use the appropriate method to make sure that you can survive those kinds of cases as well.
What's an example of an exception in a build step that you would want to catch rather than allow the job to fail?
Well, for example, if something happened in general if it's in a job, there are various constructs in Jenkins for flow control, such as retry in there that will retry an operation for a certain number of times, and if it goes past that time and still can't do it, it throws an exception. That's the way that it indicated that it couldn't complete it. And so you would need to catch that exception then to keep your program from aborting if you're using scripted syntax there, and be able to handle it gracefully and continue on.
What about if we have a step that is compiling a program and the compilation fails due to an error, syntax error in the program? That seems to me that's a pretty normal thing, and you'd want to handle that rather than the entire pipeline going into a failed state.
Well, if you have a syntax error, though, chances are you want to detect that and alert the person who did it, or somehow alert people to that first, because the pipeline can't proceed down the further steps of testing code and doing all the other steps if the code doesn't compile in the first place. Certainly you could catch that and work around that sort of thing in there too, but more normally you probably would want to at least flag that and at least notify people about it so they could deal with it quickly.
In that case, this would be a common thing, not only compilations fail, but other types of conditions where you want to notify. Are there plugins that Jenkins uses to communicate with the development team through different Slack, email?
Yeah, absolutely. In fact, there's a chapter in the book that I wrote just on about notifications in there and reporting, and we have examples in there of using things like Slack out there and other social media things to communicate status back. For any kind of application that you can think of pretty much these days that's used in software development or producing software, there's usually a plugin for Jenkins. and the social media things are no exception out there. So certainly you can have notifications back to Slack teams. You can have colors in there. You can define all kinds of criteria there. Of course, the most common one is, or arguably, I guess the most common one still is the email notifications. You certainly can send out email notifications, and there are all kinds of advanced setups for those kinds of things. So again, using plugins, you just have to find the plugin that you need, and you can pretty much tie into any of those applications.
I want to move on now, talk more about scaling and distributing Jenkins. I can download, install, and run on a single server. How many Jenkins jobs, or what can I support on one server?
I don't actually know what the limits are out there. I would say it's probably dependent, upon your infrastructure in there too. But certainly, I know I've seen a ton. That's not an exact number, of course, a ton of things out there. And I think it just depends on the infrastructure out there. Of course, you want to set up, you can set up different nodes. And one of the things you think about with Jenkins is having the master. The master is not really intended to do a lot of heavy lifting. It's more about managing the processes, managing the jobs, and having access to things. But it really has what they call a lightweight executor. So typically you're trying to farm stuff off to nodes out there, and you can define nodes, for example, that you might have a group of nodes that has a label, as they call it, an identifier, that says these are our Windows nodes, or these are our Unix nodes over here, or maybe these are on the East Coast or West Coast out there. And so then you can, in your pipeline, select the particular nodes you want to send stuff to. And that's a big advantage as well. And the other thing I'll say about the Jenkins 2 stuff, they've done a lot of integration for containers, in particular with things like Docker. So you can have a Docker file, the thing that describes how to build a container, and give that to Jenkins, and it can spin up an agent or a virtual node based off of that. So there's a lot of capabilities within your pipeline code to fire up containers and run processes on that, which gives you a lot of flexibility then distributing workloads that way.
I think you have been talking about Jenkins as a distributed system. Could you give an overview? What is the architecture of the distributed system? We're talking about nodes, so we have the server, which is the master, and then a fleet of nodes.
Right. So there's a couple of terms that are used in Jenkins, the master system, and then they will talk about, if you're working with declarative pipelines, they talk about agents. If you're working with scripted pipelines, they talk about nodes out there. For all intents and purposes, you can think of nodes and agents and stuff at the same time. But again, the idea is that I have a master Jenkins system, but I farm the work out, the various jobs, whether it's a traditional Jenkins job or a pipeline job, as we're talking about now, whatever, out to these nodes or agents out there. And an agent can be anything from a Docker container to an actual, bare metal kind of system out there, whatever makes sense. It could be something across the country. It could be whatever out there. So the real distributed power of Jenkins comes in being able to farm these jobs out and send them to the most appropriate system to run them on. And it's very easy within Jenkins because of this idea of a label. A label is just an identifier that you can attach to any of these nodes, and you can have the same label on multiple nodes. So like I said, if you had ones that run Windows, you might have a farm of systems all labeled as Windows that you could just say, send this thing to the Windows node, and it would send it automatically out there. And then the results run, and the results come back to the master, so you can see the output there. But that sort of a structure makes it actually very easy to be able to send work out and distribute the load.
If we have a number of Windows nodes, Jenkins needs to send a job. Is it going to pick one that presently is not too heavily loaded and send the new work there?
Yeah, it'll pick one that's available. I honestly don't know exactly what the algorithm is in terms of whether it's looking at the loads and stuff. I'm sure there are probably ways you can tune that, but I'm not sure how it's implemented in the underlying setup.
Are you aware if it has integration with cloud provider services like Autoscale groups, where it can spin up new capacity in line with the workload and tear it down as the workload declines?
I'm not familiar with that. I don't know exactly what it can do with that, but it might have a chance to do that.
What is a typical number of nodes or agents that a master would have? Or not a typical number, but what's a range of sizes you've seen in deployment?
Well, certainly, I know where I work, we have quite a few systems out there, probably on the order maybe of 100 or so masters and stuff, and then nodes off of that. It really varies, and I don't know. I don't know the best way to answer that. I think it varies from situation to situation out there. Anywhere from a single node to, I'm sure there are ones that have probably 100 or so if they're sitting out lots of stuff. The other factor that plays into this, and one that is more common, I think, these days, is the sort of ephemeral nodes. The idea of, they call it the cloud. There's cloud plugin for Jenkins where you can spin up a Docker container to run stuff on demand, and then when the job finishes, that goes away. Or you can spin something up in AWS out there to run a Jenkins job, and when you're done, it can go away. So it's not even necessarily anymore having a constant number of nodes always available. It can be more of the on-demand. I spin up something with Docker or Kubernetes or some of those things to run the jobs when I need it, and then when I'm done, it spins it down and takes it away.
You just answered my earlier question about Autoscale groups. What I was really getting at was ability to have job execution resources on demand rather than have a fixed number of nodes that may be idle half the time.
Sure, yeah, and that's one of the nice things. I've got a section in the book about working with containers in there, and that's one of the things we talk about. It's very simple in Jenkins. You can have things like the cloud provider plugin that goes out and spin these up, or you can even in your pipeline code just say, "Hey, I'm going to spin up a a Docker container for this, run my code in it, and then bring it back down." In fact, they call it a global variable. It's kind of like a step in the code, but there's a Docker global variable. There's an inside method you can call in your pipeline code that will get an image down for you automatically, start it up, map your workspace in Jenkins as a volume in the Docker container. Then within the inside method, has a beginning and an end to it. It has kind of a block in there. Within that scope, you can call the shell steps, the SH steps, and any steps that you run in that block will automatically be executed on the Docker container instead of on the Jenkins system itself. So, and then when you're done, this step will spin down the container and just make a little record that says it was used in there. So just by calling one method on this Docker global variable, you get all of that functionality for free in there.
The cloud providers mostly have different ways of offering a Docker container execution as a service. If you're able to integrate with that, then you don't need to host your own execution infrastructure at all.
Right.
I want to move on now and talk about how jobs are initiated. What are the different ways that a job or a pipeline could get started?
Well, typically, if you're starting with the continuous integration sort of functionality there at the front of the pipeline, you're doing it in a couple of ways. For example, you might be doing what we call polling the source management system, which says every minute, every 5 minutes, however often it is, I go out and check and ask the source management system, do you have anything new for me out there? Another one in terms of that could just be that periodically, regardless of whether or not there's something new out there, you can just go out and say, I'm going to build every hour, every 15 minutes, however that is. There's a syntax out there. It's harkens back, if you know the old cron syntax out there, to be able to specify the day, the hour, the week, that sort of thing, being able to specify that for either polling or for just periodically building out there. A couple of other ways you can do it. There is a tool called Garrett, which is designed to do kind of code reviews, but you can also have it kick off builds. It basically works with Git and kind of catches your code before it gets all the way into Git and says, let me do things like code reviews and verify changes, and it can communicate with Jenkins and kick off test builds from that. And then finally, there is an approach called like a webhooks out there. If you have code on GitHub, for example, you can define a GitHub webhook which will send a notification, they call it a payload, over to your Jenkins system when something occurs on GitHub. If somebody makes a change or updates a file, whatever the case may be, it will actually do kind of a push notification, send it across the way to your Jenkins system. Of course, for that one, that implies your Jenkins system has to be accessible, has to have a port open that GitHub can communicate to. But so there's a couple of different ways out there to kick off the builds.
You said something I want to drill down into a bit more. Typically, developers changing systems will create a branch in Git. Did I understand that we could have Jenkins run, let's say, a number of tests, manual steps like a code review on the branch before it gets merged? So I don't want to deploy it, but I do want to have different kinds of tests passing before I consider it ready to merge.
So that's more of a function of the pipeline out there. I was referencing an application called Garrett, which is a separate application that you can install and have in your pipeline that allows you to do the code reviews and also integrates with Jenkins to do pre-builds out there. And you can use that as one of the applications with the Jenkins pipeline out there. There are also other applications. I mean, GitHub has code review stuff in there, and GitLab, those things. A lot of tools have code review and those sorts of things built into it. But certainly once you get your code into the source management system as well, so those kinds of applications let you look at the code before it gets into the source management system all the way. Once it gets into the source management system and the pipeline pulls the code out, then part of the typical continuous delivery pipeline is running the integration testing, the functional testing, and all those successive levels of testing out there to be able to prove the quality of the code and to prove that it works in there. So you've got kind of both before the pipeline and kind of as it's in the pipeline covering that.
If I understand this, I might define a Jenkins pipeline. Let's say I call it developer pre-commit, and that pipeline consists of compile the code, run some integration tests, maybe run some unit tests, produce a report. But that pipeline would not include a deployment step. And it's up to me to use Garrett or some other tool to say when I want to run that Jenkins pipeline. And then I would wire that pipeline up to run on branches when the developer is ready to merge. Is that it, more or less?
Kind of. Essentially, if you had like Garrett out there, Garrett has a plugin that integrates with Jenkins. And so it would be, you would probably define a Jenkins job that would say, when I put code into Garrett before it gets all the way into the Git remote repository, I do we might call it like a review job or a small review task in Jenkins. And it only may just say, when something gets into Garrett, let me try and build it and report back on it there. And then once you go ahead and get that successful, you could go ahead and say, merge this in. The code's passed the basic sanity check out there, the review build. Go ahead and merge it in, and then you could have your other pipeline, as you're talking about, kicked off from based on that code being merged in finally, and then that would kick off the rest of the downstream processes.
I want to talk about some security aspects. Many of these things that Jenkins needs to do, like pulling Docker images from a registry, interacting with cloud providers, are going to require credentials. How does Jenkins manage the credentials it needs?
So Jenkins has a whole, for lack of a better word, ecosystem around credentials and built in you can define credential providers, you can define credential stores, you can define all kinds of credentials in there, of course, SSH keys, certificates, password, username, passwords, those kinds of things. So there is a whole credentials system built into Jenkins. In fact, I devoted a whole chapter in the book to around the security aspects and credentials in there. So the basic idea is you define the credentials that you want to use in Jenkins, and then within your pipeline, you have steps available that can use those credentials. And it's kind of cool. What they typically do is they'll say there's a step, say, with some credential. You can define that step. And what it does is it takes the credentials you've identified in Jenkins, takes the values, and puts them into environment variables. So you can give it environment variables names, and then you can use those environment variables in the rest of your code without having to expose those things. So you're telling Jenkins, go out and grab those values out of the credentials, put them into these variables here. I'll use the variable names in my code, and so you can reference those without ever having them exposed out there. Or in the case of like SSH keys, you can just say with SSH key, and you have a block of code, and as long as you're doing something within that block, it has access to those credentials.
We did a show on HashiCorp Vault, and I'm aware that cloud providers have some similar services. Are you saying then that Jenkins has integration with services like this? It can communicate and say, I need the certificate to get this resource from this other place. Give it to me now.
Yeah, Jenkins has, again, you define the credentials up front that you want, and then it's very easy to access them in there as well. And I actually did a little section in the book, in the credentials thing, where I talked about some very simple integration with Vault. It's probably gotten more sophisticated now, but did talk about using some of the Vault, driving some of the Vault stuff from there. So certainly, again, as these new products come out, new features come out, there's more and more plugins to integrate with them. But the credential system works pretty well in Jenkins.
If you are running your own nodes as servers, the master has to get access to them, maybe SSH, or how does the master authenticate itself to do work on one of the nodes or agents?
So there's a couple of different ways. Most commonly, it's probably done via like SSH, having SSH keys there between the master and the node out there. There are some other ways, some of the more traditional like JNLP stuff. You can start up nodes that way. You can authenticate various ways. The most common way that I've seen it done is like through driving the SSH keys out there.
Does Jenkins implement users, and is there a permissioning system for users?
Absolutely. Jenkins, by default with Jenkins 2.0 now, it is secured from the start. So you go through the installation process, and it generates a random password, and you put the password. You have to go and find that password and put it in to finish installing it to set up the initial user. But there is a whole system around user and user permissions. Again, it's covered in that section on security there. You can define various sort of security models. There's a role-based access plugin you can get to define it based on roles out there. There's also the Jenkins typical kind of matrix setup where you can define users, and you can use the matrix rows and columns permissions to check off what permissions people have and stuff in there. And it's actually kind of cool, since we're on the topic about users and security here. One of the things that they've done in Jenkins 2 is, if you think about it, when you are writing a script, you're writing a pipeline script, you can call any kind of method you want. You can code any kind of thing you want to in your script. Doesn't necessarily mean you should be allowed to do that. So one of the features they have is called in-script or process approval out there. Basically, if you're an administrator, you can run any kind of script you want. They assume you know what you're doing. If you're not an administrator, then what Jenkins will do is it can look, if you're using a thing called the sandbox, and say, what methods are you calling in your pipeline code? And are those methods allowed? It has a whitelist that it keeps to say, is this method okay to be able to be used out there? If it's not one of the allowed methods, then it will actually create a queue of and send something to an administrator. It says you can't run your script until an administrator looks at this and approves it. And it has a little in-process script approval out there where an administrator can log in and say, okay, this script is okay, or this method call is okay, or it's not okay, or it's okay if the user has permission to run it. So that's, they thought ahead to that at least. So it's not just like you can code up anything and run it. It's actually tied into the permission system and into the good list to make sure that it's okay to do.
We were talking a little while back about you could have GitHub, when a new commit comes in, it could launch a job through a webhook to test the code in that commit. Does the GitHub webhook authenticate as a specific user that has permission to execute that job?
I'd have to go back and look at exactly what it does in there, but I certainly think that you have to have authentication set up for the webhook. I don't remember exactly how that works through the process there.
Let's move on now and talk about deployment. I'm roughly going to define that as moving your code to run on a staging or production network, and that might involve restarting parts of the system. Is that something I would use Jenkins for?
Well, typically I think of deployment. Deployment can mean so many things these days. As you said, it kind of roughly is putting it out there so it's available to use, but it could mean it's deploying it out to a cloud system. It could mean that it's making it available on a website. It's just putting a set of executables out somewhere for it. So depending on the application and if you have a plugin and stuff, certainly you could drive that through Jenkins. If you have a process that can be automated to deploy your stuff out there, there is no reason why you couldn't use Jenkins to do that.
The deployment then, it might be a shell script, or there are tools like Capistrano that give you the ability to define scripts that will move your code. So Jenkins doesn't necessarily know it's doing deployment. It's doing a job, and you define that job to do deployment steps as you see it.
Right. I mean, there are plugins, I think, like for Capistrano and different things, and even if it's just deploying it into a Tomcat system or something like that, it's fairly easy to have Jenkins be able to do that. Any kind of command that you can use to execute that should be able to be done by Jenkins out there. A lot of times these days too, it might even be deploying it into a container, creating a container and putting it out there. I've had jobs that I've created that spin up Docker containers or create a WAR file, take the WAR file, put it into Tomcat, build a Docker image off of that and a Docker container and link containers together. So really anything that you can drive, particularly via some kind of a command line interface or a plugin interface, something like that, can be used.
We have a show coming up more specifically about deployment. It's an interesting process in that you can have a lot of failure modes, and you have to decide or maybe set a policy that you roll back or you roll forward. Is that something you'd want to delegate to Jenkins?
I guess it kind of depends on what your criteria are. One of my favorite quotes about deployment, and I'm drawing a blank on who, I think it's Carl Baum, or I can't remember the fellow's name, but basically he said that continuous deployment doesn't mean that you always deploy every release. It means that you've proven that it can be deployed out there. Certainly there are things like Kubernetes and stuff now that do the clustering technology and rolling out versions and things that make it easier to roll back. So if you have a plugin or something with that, you could probably make it work. But I think one of the ideas is if you're using deployment schemes like blue-green deployment, those kinds of things, it's probably going to be more of a manual flip the switch and decide which one. Is it really good enough? Is it ready or not? If you're just rolling it out there just to make it available without putting it into production, then certainly you could do that. There's no reason, again, you couldn't drive it with Jenkins to automatically deploy it out there, and certainly some companies do that. They always just get the latest and just assume it. But you might also want to have a human kind of gating that decision as well.
This isn't really a Jenkins point, but I'm aware there are organizations that are doing hundreds, thousands of deploys per day. At that scale, you'd probably want a computer making a lot of the decisions and not having a person have to do all that.
Absolutely. If you're one of those organizations where you are just always putting out the latest, then certainly you could want to automate that, and that would certainly be something you could drive through Jenkins.
I want to spend a little time on the implementation of Jenkins itself. What language is it implemented in?
I don't honestly know. I think it is probably Java, but I'm not entirely sure.
Is it open source?
There is an open source version of it. Certainly, there's also an enterprise version of it, but there is open source as well.
Does it have a corporate sponsor that contributes most of the patches?
Yeah, there's a company called CloudBees out there, and the gentleman who originally created Jenkins is the one of the heads of CloudBees out there. And they do enterprise support for Jenkins. But the really nice thing about the relationship with CloudBees is they are part of the Jenkins community. They are a big part. And the vast majority of what they work on gets contributed back to the open source version out there. So it's not just like a company doing things. They are part of the open source community. They're engaged with other people out there answering questions, those kinds of things. So yeah, it's a cool sort of relationship in that they're giving a lot back to that while they're also supporting the enterprise aspects of it.
I want to move on now, and this will be our last main topic, is adoption. Suppose we're in an environment which does not have a build server, meaning that all these tasks would be done manually or maybe ad hoc or custom tools. Where does the advocacy for adopting Jenkins usually come from?
Honestly, I think it probably comes organically through a lot of organizations out there. I typically have seen these sorts of things come from a group who says we have to do something, we have to find a way to do something better, we have to be more efficient in it, we're spending too much time on this, and they start looking for an answer out there. And they start looking probably at what is considered quote unquote industry standard, or what do a lot of people use, and so they'll get something and try it, and if they get it and try it, then that message gets communicated via word of mouth or via experience to other groups out there. Developers are very smart. They're going to find the best way so they can spend most of their time coding and not have to worry as much about this sort of these pieces of it. And that's part two of what the DevOps movement is too. I think when you get operations people working with development out there, they're both looking for the best solution, and something like Jenkins that provides this kind of workflow automation through it. Once people start to see what it can do, then they start to think about other ideas and other opportunities and things they can use it for. The other way I think it comes into is, as I said, there's a huge ecosystem of plugins out there. And so pretty much any of the major, even open source applications out there these days that do tooling kinds of things will have a plugin for Jenkins. So a lot of time you start looking at the tool like Git or something, and you see, oh, there's a plugin for Jenkins, and wow, that would be cool if I could have my builds automatically kicked off, or have Jenkins detect changes in my source control and kick off the builds out there. So I think all those factors kind of play into it. So it's more of a breadth, sort of a bottom-up kind of advocacy that happens maybe than more of a top-down.
Some DevOps tools, and I'm not sure whether it's fair to group Jenkins as a DevOps tool, but they are specialized enough that you mostly find skills for writing, for example, Puppet or Chef scripts in the DevOps team versus other skills like shell scripting that you'd expect everyone could do as needed. Are the Jenkins files, would you typically have a DevOps or a build and release engineer who's mastered the Jenkins file language, or is this something really everyone's going to be expected to write their own Jenkins files for their modules?
I think it's probably going to vary by organization, but first thing I would say is that DevOps, or Jenkins, is very much a DevOps tool. Their conferences and stuff now are kind of geared towards that whole DevOps model, and I think it does provide that sort of the DevOps functionality, some of that's been missing for a while. But I have seen even in where I work and stuff that developers, have been willing to jump in and write Jenkins jobs and work with that. The nice thing is, like I said, if you're a programmer, writing your pipeline as code, programming your pipeline probably feels pretty natural to you. Being able to use constructs in there and steps and write code and test it and run it, those sorts of things, probably feels more natural to you now than perhaps filling in the web forms did before out there. So I think the pipelines as code has opened up perhaps more doors to using Jenkins and access there. But I think it's been, what I've seen is that it's really not been the case that people are really hesitant to use it or kind of put it off to other people. Now, you may have a group, of course, that wants to have standard ways of doing things, creating what we call shared pipeline libraries and stuff, standard ways of doing things out there. But I think it's a very low cost of entry for anybody who wants to work with it.
I could see this spanning across concerns of many different groups because the developer generally knows how to compile or build and package their application, but the DevOps would have a better idea of how do we get this pushed out onto the production network, which machines does this piece of code need to run on. So it's kind of a cross-cutting thing.
Yeah, absolutely. And there are certainly other tools out there like Gradle, the Gradle build system, which can run test cases and those sorts of things. You can define targets or tasks, they call them in Gradle, to those kinds of things and invoke those from Jenkins. So you can actually have your testers writing tests, and people writing deployment scripts and stuff. And then Jenkins, again, just becomes kind of the orchestrator at the higher level. So as long as you can say, this is how you invoke my part of the process, then you can translate that into a Jenkins pipeline easily.
We've covered pretty much everything I wanted to about Jenkins. Is there anything you wanted to mention or want us to cover that we haven't hit on?
I guess I would just really quickly mention that there is a new graphical interface they're working on called Blue Ocean out there, in that it's still a little bit rough in some spots out there, but I think in the future it's going to provide a nice sort of graphical interface for people who aren't as comfortable diving into writing pipelines as code, being able to look at that. There's also the concept of shared pipeline libraries I've touched on just briefly, but the idea of being able to take your code and kind of put things in there that you want to share across groups. It's basically a source management repository with a certain structure. You put your code in there, and then there are ways to bring it into the Jenkins pipeline as well out there and use that. So that's a very nice thing to have out there. And I would just say I think that it's really worthwhile for anybody who's looking to do continuous delivery. And I don't work for CloudBees. I'm not getting anything from this, but I'd say from my experience, Jenkins is a very easy to use tool. It does seem to have a lot of flexibility now, and I really feel like with the whole DevOps movement in here, it provides a lot of opportunities for groups to migrate towards that.
I'm glad you brought up the point about shared libraries. That was something I had wanted to ask you about. What I've seen in Jenkins 1 is absolutely no modularity, so tons of copy and pasted jobs, and you'll see job XYZ, job XYZ-1, job XYZ-2. Somebody wanted to run it slightly differently. The idea that the Jenkins jobs are now going to be code is great because now we think more like programmers. So of course, the first thing I want to do as a programmer is, can I create a module or a function or something I can call from different places and have it run the same way so I'm not copying and pasting. Sounds like they've solved that problem or going in that direction.
Yeah, I think that the shared pipeline libraries are a nice way to do that. Of course, I mean, if you sometimes you can parameterize things and that sort of thing, but if you want to just have common code, there is a shared pipeline library structure out there. There's essentially three parts of it very quickly. There is a resources area. So basically, you're just defining a structure. And resources is one. It's for like data files out there, JSON files, any kind of data files you want. And then there is a source area, SRC, which is more like the kind of Java source path out there. That gets added to your class path automatically when you're using that. And then there's one called vars out there for these global variables. And that can be pretty much any code defined in a Groovy script or Groovy file with an object and methods and such on it. And the vars is probably the easiest to use. But yes, you can take that, create that structure, put it up in a source management repository, configure it in Jenkins, say, Jenkins, this is where my shared pipeline library is. I'm going to call it foo. I want you to get it out of this branch, use this version. And then once you've defined it globally in Jenkins, your script can bring it in. There's a couple of different ways. There's an annotation, at library annotation, you can bring it in. And then in Declarative, there's another way to bring it in as well. But you can bring that in. And the cool thing about that as well, I mentioned the declarative and the scripted syntax, and I said there were some things you could do in the scripted syntax with like loops and variables that you couldn't do in declarative. You can always create your pipeline library as scripted syntax and still load it in declarative and get that functionality. So you can get kind of the hybrid approach, the best of both worlds out there.
Often the case with declarative programming, 5% of the time you just have to write a little bit of imperative code.
Yes, absolutely. And there are a couple ways to work around that. There actually is also a script block that you can put in your declarative to actually use some localized scripted syntax, but the pipeline libraries are probably your best bet in that case.
Let's move on to wrapping up the show. For our listeners who'd like to find your book, where can they obtain it?
Probably the easiest way is good old Amazon out there. If you go out there, Jenkins 2 up and running, you should find it out there. They've been kind of running low on copies lately, but I understand they're getting some more in out there. So just check out. You can search by my name or Jenkins 2 out there on Amazon.
If any listeners would like to contact you or follow you, where can they find you?
I'm at Brent C. Laster on Twitter. BrentClaster is the last name. Also on LinkedIn under Brent Laster out there. So yeah, feel free to reach out to me. Always happy to talk to people about topics like Jenkins or Git or continuous delivery.
Brent, thank you very much for speaking to Software Engineering Radio.
Thanks, Robert. I've enjoyed it. Appreciate you having me on the show.
For Software Engineering Radio, this has been Robert Blumen.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.